In this series too, I will introduce surveys and research conducted by the Total Zero Defect Study Group with Mr. Shigehiro Nakamura, as well as examples of companies that have implemented the method to achieve zero defects. Furthermore, many companies have already achieved great results in a short period of time using this method, and I would like to introduce the key points of these results for your reference. Investigating the cause of defects always requires the action of fact-finding analysis. This table shows the specific measures that have been compiled and utilized by the TZD study group. The light blue represents measures against physical phenomena, and the yellow represents measures against human error. Today, I would like to introduce how to utilize this method with examples in this video. I introduced how to proceed with zero defect measures in Series I, but when you take measures to deal with defects caused by physical phenomena, go to the site where the defect occurs, use scientific analysis procedures to examine the actual product and phenomenon, fact-check one cause for each problem, and proceed with one measure. If you eliminate the cause using this approach, you will end up with something like the bottom of this diagram. However, since there are many examples like the one at the top of this diagram, I would like to warn you that you should not use the brainstorming method, and also introduce some other points to be aware of. When a defect occurs, there is a method of gathering all the people involved on site to investigate the actual situation. This is not a problem when the investigation is limited to investigating the facts related to the defect in question. However, there are many cases where the people involved assume from the beginning that there are multiple causes and seek countermeasures using a brainstorming method. Therefore, in this picture book, we explain as an important point that this method is unrelated to identifying the cause of the defect. Defects related to physical phenomena can be reduced to zero by visualizing the causes and effects, as well as the mechanisms by which the defects occur, as shown in this diagram, and then eliminating the causes. This was an example of a measure taken to deal with small particles of dust that got into the camera. In the past, those involved had struggled to find a solution to what they considered a chronic defect, but by first capturing the problematic dust, identifying its components with an investigative microscope, and analyzing the mechanism by which it occurred, the problem was reduced to zero. I would like to introduce a part of this picture book. This is because it concretely illustrates the story mentioned above, and I believe it will be effective in helping you understand the contents of the book. This case study is from a company training session in the UK where Mr. Nakamura was consulted. The first topic was a 2-day video improvement training session attended by people from various industries. However, since the participants only learned the technique in 1 day, the company's top management asked Mr. Nakamura to come up with a solution to the defect the next day. This company selected 4 themes. All of them were analyzed in 1 day using the TZD study group's methodology for zero defect measures. I will now introduce the failure analysis of the plug shown in the diagram. The trainees worked in groups to analyze this subject. Using video analysis and YY analysis, shown in part of the diagram, they analyzed the factors deeply related to the problem occurrence on site. I will continue my explanation, and you will find the details in this picture book. The problem situation, which was videotaped in this case, is shown in the photo on the left. In this case, the problem was guide wear. However, the guide should not have worn down to this extent. This is because, in metallurgy, the hardening process should guarantee the guide's lifespan. However, when we measured the hardness of the shooter part of the guide, we found that it was not hardened. Therefore, we replaced it with a genuine guide, and the loss of $33,740 per month was reduced to zero. In addition to the defective plugs, this company was also having trouble with many other defect prevention measures. For this reason, They had previously consulted on defect prevention measures and had been proceeding with the measures shown in the diagram on the right. However, although many study materials were created, this type of method did not reduce the number of defects, and they were troubled. In response to this, they used the TZD study groups method, some of which I have introduced on the left side of the diagram, and were able to clarify the causes of the defects in one day. This was the same for other training themes. At this company, relevant parties were gathered at 3 o'clock on the second day to introduce examples of defect prevention measures. At the same time, the company's top management banned all engineers from creating documents in their rooms for the next 3 months and ordered them to implement defect prevention measures at the manufacturing site using the TZD study groups method. 3 months later, Mr. Nakamura received word that the company had achieved 0 defects. This is the difference between the brainstorming method and applying this method, but this picture book introduces many such examples, so I urge everyone to take a look. The analysis of defects due to physical phenomena is not always limited to cases where the cause of the defect can be reliably identified by measuring the actual item on site. In such cases, it is effective to utilize comparative analysis developed by NASA. This picture book also provides a detailed introduction to this method and provides examples. Thank you very much for watching the introduction to this picture book. The above explanation is the gist of this picture book. You can also get it at this URL. Amazon Prime members can watch it for free.